Show that this expression here can be written as cosec squared x. Hence solve this equation. Give the values of x to the nearest degree in this interval. Part C. Hence solve this equation equals this. Giving the values of theta to the nearest degree in the interval of theta between 90 and 0. Okay, that's the question then. I've got it summarized all here. So we just want to show that this can be written as cosec squared theta, don't we? So I'm going to overwrite the question because they're so long to write. So we want to show that equals cosec squared, don't we? So I'll start from here then. That equals sec squared x. And here we've got sec, difference between two squareds. So it's sec squared x minus 1. And that's equal to, now sine squared plus cos squared equals 1. So sec squared, if I divide by cos, we'll have tan plus 1 equals sec squared. So sec squared minus 1 is none other than tan squared, isn't it? Okay, so sec squared minus 1 will equal tan squared. So I just reminded myself, of that identity. So this is tan squared, so it's 1 over cos squared. That's the sec squared there, and then times by tan squared x, and that's equal to then sine squared over cos squared. The cos squareds will cancel, so we're just left with 1 over sine squared, and that's of course cosec squared x, which is what we wanted to show. So we've done that then. So B, so we've got the left hand side then, and that's equal to cosec squared, and hence solve this equation here. So part B then. So here we've got cosec squared then on the left hand side for this is equal to cosec x plus 3. Move these two terms over then. We have a quadratic in cosec squared x. Move it over, the cosec, and move the 3 over through the equals. Flip its sign of both of those terms. So we end up with cosec x, and I don't think it factorizes easily, does it? We need to solve it though. So let's use the formula then. So we've got a quadratic in cosec x, so cosec x equals minus b, 1, plus or minus the square root of b squared, minus 1 squared is 1, minus 4 times a, which is 1, times c, which is minus 3, so that makes that a plus, put 3 all over 2a, 2 times 1, which is 1 plus or minus the square root of 12, plus 1 is 13 over 2. So that tells us then that sine x, if we invert the fraction now, is equal to 2 over 1 plus or minus root 13. Now the difference, 1 minus root 13. So let's have a look at these on the calculator then. So that equals, so the first one will be 2 divided by bracket 1 plus root 13, close bracket, equals the decimal 0.43, 0.43425, and then we want to put the minus 1 in, see what we get there. Delete that and put a minus, decimal, minus 76759. Let's just check that. Okay, that's fine. So we've got that then. So there's sine x. Now what does it say? Hence solve this equation for x between minus 180 and plus 180. So let's have a look at that then. Let's draw a circle. Draw a circle. Sine x equals 0.43425 then. Okay, so sine is positive here and here. So we're going from minus 180 to 180, aren't we? Okay, so that's where we're going from and to. We write CAST. And we know sine is positive here and here. Draw two lines. Mark off alpha to the horizontal. And simply write sine alpha is equal to the value without the minus. Then we want shift sine and get alpha. So let's just go back and get this number, because it was plus, wasn't it? This one. It was the plus one, wasn't it? That's in answer now. And then it's shift sine of ants. And that's it. 25 point to the nearest degree. Well, we'll keep it accurate to start with. 25.738. 25.738. So theta then here is equal to, the first solution is round to here. Minus 180 to 180 would be 25.738 degrees. And the next solution will be round to here, which is 180 minus the 25, which is 154.261. Let's just tidy this up. 261. Okay, degrees. So there's our two solutions for this theta in the said range. Now the other value. So here's sine x equals minus 0.76759. So we draw a circle again. Write CAST. This time sine is negative. It's negative here and here. Draw two lines. Mark off alpha, the associated acute angle, and simply write sine alpha equal to the number without any minus. 0.76759. Okay, so shift sine on that, and we can get alpha. So it's probably accurate enough, isn't it? So it's inverse sine of 0.76759 equals 50.1379. 50.137 degrees. So theta is equal to then, the first solution is round to here, going to the minus 180, will be minus 50.137 degrees. And the next solution will be round to here, which is back 180 plus 50.137, which is 129.86 degrees. That's it. So those are the two solutions for the set here. This is a minus, of course, because we're going round to minus 180 in that range, from 0 to minus 180 just underneath here. So we get those two solutions. So the final answer then, to the nearest degree, here theta is equal to 26.154 minus 50 and minus 130 to nearest degree. So that's part B done. Okay, let's go back up. Now it's the same equation here, but it's saying solve this equation here to nearest degree for theta between 0 and 90. So theta between 0 and 90, we've got 2 theta. The argument, instead of it being theta in our original problem, is 2 theta minus 60. We're solving between 0 and 90. So this is part C now. We're solving between 0 and 90, so 0, double everything, 2 theta is less than 180. So our solution set will be 2 theta minus 60 will equal, the range is 26 and 154. But I'm going to keep it as more accurate than that, just in case we get a problem. So I'm going to put the original values in, 25.738 and 154.261. The reason we can write this quite so simply is because in part C, this equation, which has an x actually, not a theta, and I've done it for theta, I think. I decided to start going to theta. This should be an x, shouldn't it? So let me just change that then, so there's no confusion. This is an x here and here. Okay, so that's our solution set then. For x. Now the reason we can do it, let me just go back to the question. This equation is identical to this one in every respect except for x is replaced by 2 theta minus 60. And the solution set's just a different range, isn't it? But here if you double 2 theta, 2 theta minus 60, oh that's interesting, because we've got to change the range here. So 2 theta minus 60 then. And this is the solution set, and that will be 120 degrees. So from minus 160 through to 120, we've got to write down the solutions from these in this range. And clearly, it's only going to be the 26, which is this one more accurately, and it's also going to be the minus 50, not this one. So let's put that in. So it's minus 50.137. So those are the two solutions. And now instead of x, we've got this same identical equation for this range solution sets and for 2 theta minus 60. And now we can work out theta, can't we? So that tells us that 2 theta, add 60, we get 85.738, and we get minus, add 60 to this, 110. No, add 60, sorry. We get 9.862. That's it. Okay. So we get that. 60 take away 50.137 is 9.862 degrees. So divide by 2. Theta is equal to then. So let's just tap that in the calculator so we've got no confusion. 85.738 divided by 2. 42.896, which is 43 degrees to nearest degree. And we've got 9.862. Let's just tap that in. Divide that by 2. And we get 4.931, which is 5 degrees to nearest degree.